students, and welcome in the session of class 10th Science, Chapter 3 Light, Reflection and Refraction. As the name of the lesson only suggests that two main phenomena we have to study in the chapter. One is reflection and the other is refraction. Reflection part we have already completed along with the spherical mirrors, as a reflection always occurs on the surface of the mirrors. So that part is over. Now today we are starting with the second most important phenomena of the lesson, that is refraction. So today we are going to study about refraction, absolute refractive index, relative refractive index. Make sure these two are different. Absolute refractive index, relative refractive index. Then what are the causes of refraction? Laws of refraction, direction of the bending of light, then condition for no refraction, and refraction through the glass slab. These are the topics we are going to cover today. So let's start with the first concept, that is refraction. Let us first try to understand this phenomena. Students, you have studied that in reflection, when the light strikes the surface of the mirror, it bounces back and it goes back to the same medium. But what happens in case of refraction? Let's find out. So, the phenomena of change in the path of light in going from one medium to another is called refraction. In reflection, light was not crossing the medium. It was bouncing back and moving to the same medium only with the change in the direction. But what happens in refraction? Light passes from one medium to another medium and changes its path. Okay, we all know that light has the property of rectilinear propagation, that it always travels in a straight line. But in case of refraction, when a medium changes, okay, just see and have a look on this diagram. Now in the cup water is filled and a pencil is kept in water. Here you can see that at this point, this is the point where refraction is occurring. Now above the medium is air, fine, the medium is air, air is the medium, and here the medium is water. So medium is changing, light is traveling from air to water. Okay, so whenever there is change in the medium at this surface only, the light changes its path, and this phenomena is known as refraction. It is the change in the path of the light from going from one medium to another medium. So when light passes from air medium to water medium, at the surface of these two medium, this is the surface where these two mediums are meeting. So at this surface only the light get refracted, means light changes its path. You can see now the pencil from outside looks like it is broken. Okay, so this is due to refraction of light. Okay, so phenomena, or you can define it in this way also, phenomena of bending of light from its original path. As usual, light should go like this straight, but it bended, and this bending of light from its original path on changing the medium, that is called refraction of light. Okay, and refraction always occurs at the boundary of the two medium. This is the boundary where the two mediums are meeting, so at this point only refraction occurs. Fine, I hope the definition is clear to all, that refraction is the bending of the light from its original path on entering into another medium. So always when we will talk about refraction, always keep in mind that the medium is going to change and the light bends. Fine, now let us go much more deeper into this concept. Okay, now refraction of light we'll again try to understand with the help of this diagram. Now in this diagram you can see that this boundary is the boundary where the two mediums are meeting. Okay, now suppose this is air medium and this could be water or glass, anything, any other medium is there. So light is traveling from one medium to another. Fine, so now what happens? Now you can see here, this is the incident ray. Fine, the ray which is incident or which is coming towards the surface, towards the boundary of the two medium, is known as the incident ray. Now The point where this incident ray will meet with the medium, boundary of the medium, this is the origin point, right? At this point, when we draw a perpendicular line, which is here shown with the dotted lines, so this perpendicular line drawn is known as normal. Okay, this makes 90-degree angle with the surface. This is the 90-degree angle. So a perpendicular line we have to draw at which point? At the point where the incident ray touches the boundary of the two medium. Okay. Now from here the refraction process starts. Fine. Because this medium is different and this medium is different. Suppose this is air and this is water. Okay. Or glass. Any of the two medium you can assume. So now at this point we have to draw the normal. Now you can see here that this incident ray makes an angle with the normal. Okay. So this angle which the incident ray makes with the normal is known as the angle of incidence. This is called the angle of incidence, which is represented by small letter I. So this is angle I. Students, remember that this angle is with normal, not with the boundary. This is wrong. If you'll mark it here, this will be wrong. Fine. So this angle is always with normal. Remember. Now, what happens now? You can see that light has bended here. Otherwise, you can see this dotted line. If light has the property to go straight. Okay. So if it goes straight, it would have to go like this. Fine. But instead of going in this direction, the light has bended. Okay. And this phenomena is only known as refraction of light. So you can see here that light has bended towards normal. Okay. If it goes like this, then it will be away from normal. But here it is bended towards normal. And this ray, which is bended now, is known as the refracted ray. This one is known as the refracted ray. Fine. So this refracted ray, which is it makes an angle with the normal, and this angle is known as the angle of refraction, which is represented by small letter r. Fine. So this is angle of refraction. So we have two angles now. One is angle of incidence and other one is angle of refraction. I and r. These are the two angles. Okay. Now, the angle which is found between the extended incident ray and refracted ray is called the angle of deviation. Now, you can see here that this is the refracted ray. And if the ray goes straight, then it goes like this. Okay. Now, in between the back extended, if we back extend the incident ray, then it is going in this direction. Okay. Which is shown by dotted line. So, angle between this incident ray and refracted ray, this angle is known as the angle of deviation. Means how much the light has bended. This is shown by angle of deviation. The light has deviated from its path. The light has bent from its original path. This angle is angle of deviation, and it is denoted by small letter d, or del is also used. Okay? Now, in case of refraction, the angle of refraction is never equal to angle of incidence. What we have studied till now in reflection, that angle I is always equal to angle R. But here I is never equal to R. Fine, I is never equal to R. This is the case in refraction. Remember, angle I is never equal to angle R because the light always bends either away from the normal in this direction. Somewhere light can go like this, or it bends towards normal towards this side. So both the cases may occur depending on the mediums. Okay. So one may be smaller or larger than the other. Either I will be larger than R or R will be larger than I. Okay. So both the cases can be there, but I is never equal to R. Fine. Now moving on to the next slide. The next concept is refractive index. Now we have to study refractive index of the optical medium. So what is optical medium first? The medium through which light can travel is the optical medium. Right? So refractive index. Now everyone knows that the speed of light in vacuum is represented by the letter C. Okay, and the speed of light in air and vacuum is almost same and is 3 into 10 raised to power 8 meter per second. This is the speed of light, you can say, in vacuum or in air, because it is same. Now, a transparent substance in which light can travel is the optical medium. Okay, a transparent medium through which light passes completely, through which light can travel, is called an optical medium. Now, a medium, remember, now these definitions you have to learn. A medium in which speed of light is more is called optically rarer medium. The medium in which the light travels faster or in which the speed of light is more is called optically rare medium. Fine, lighter medium. And the medium in which the speed of light is less is called optically denser medium. And naturally, when the medium is dense, the particles are more closer, then those particles will obstruct the speed of light, and hence the speed of light is less, and the medium is called optically denser medium. Okay. Now, light travels faster in optically rarer medium and slower in case of optically denser medium. If the medium is rarer, the speed of light will be more. If the medium is denser, the speed of light will be less. Okay. Now, speed of light in air is 3 into 10 raised to 8 meter per second. Speed of light in water is 2.25 into 10 raised to 8. And speed of light in glass is 2 into 10 raised to 8 meter per second. So, which one is the most rarer among this? Yes, air is the optically rarer medium among this, because speed of light is more in air. So, it is, when the speed of light is more, that means it is optically rarer medium comparative to water and glass. Okay, if you compare water and glass, then speed of light is more in case of water. So, water is a rarer medium comparatively to glass. So if you compare all the three, air is the rarest one and glass is the densest among these three. Fine. So we'll be dealing only with these three only, but in your textbook some other mediums are also given along with their refractive index. Okay. So I think these two terms are very clear: optically rarer and optically denser. Optically rarer, in which the speed is more, and optically denser, in which the speed of light is less. Now let's move on to next slide. Absolute refractive index now. So in the last slide, we just find out the speed of light, rarer and denser medium. Now actually we are starting with refractive index, which is of two types. One is absolute refractive index and the other one is relative refractive index, which we'll do later on. So let us see first what is absolute refractive index. So it is defined as the ratio of speed of light in vacuum and the speed of light in the medium could be any, it could be air, it could be water, it could be glass, like this. Fine. So here it is written, refractive index first is represented by the letter small n. Fine. So what is n now? It is the ratio of speed of light in air or vacuum, because it is same, so you can write here air or vacuum also. So speed of light in air divided by speed of light in any material, in any medium. Fine. And speed of light in air is represented by the letter small c, and speed of light in any medium is represented by small v. So refractive index is c upon v. C by V. C is representing speed of light in air and V is representing the speed of light in any medium. Fine. Now, as refractive index is the ratio of two velocities, okay, two speeds we are dividing. So it's a ratio and ratio has no units. So refractive index has no units. This you have to keep in mind. Refractive index is just a number, it has no units. Fine. Now we'll take one example, that refractive index of glass, right? When we are finding the refractive index of glass, so here means this medium is the glass. Okay, so what, how to find out now? So formula is c upon v. So c is speed of light in air, so we'll put 3 into 10 raised to 8 upon, now what is speed of light in glass? It is 2 into 10 raised to 8. So 10 raised to 8, 10 raised to 8 will cancel out and you will get 3 upon 2 here. So 3 upon 2 is equal to 1.5. So this 1 upon 1.5 is the refractive index of glass. The medium whose refractive index we are finding is always taken as denominator. Keep in mind, and numerator will be always the speed of light in air. Okay, by dividing it you'll get a value which is equal to the refractive index of that medium. Okay, now one more thing to remember, that refractive index is a characteristic property of the medium whose value only depends on nature of material of the medium and the color or wavelength of the light. Okay, so refractive index depends on the nature of the material or the medium and the color or the wavelength of the light which is passing through it. Okay, now the more the refractive index, more denser will be the medium. Fine, this you will now understand here. So that was absolute. Whenever we are comparing the speed of light of any medium with air, then it is called absolute refractive index. Okay, whenever there is c by v, whenever we are using c means speed of light in air, we are comparing with any medium, then it is absolute refractive index. But if we find the ratio of the speed of light of the two different mediums, means both the mediums are different other than air, then it is relative refractive index. Okay, so when light passes from one medium to another, the refractive index of medium 2 with respect to medium 1 is written as. Now remember children, here we are taking again two mediums, but neither of the medium is air. We are taking two different mediums. Okay, if we take air as one of the medium, then it becomes absolute refractive index. But now other than air we are taking. So suppose we have two mediums, medium 1 and medium 2. Medium 1 and medium 2 we have. Fine. So refractive index is represented by n. Fine. And refractive index of medium 2 will be as n2. Now what happens here? Now we have to find the ratio of 2. Suppose we have to find first the refractive index of medium 2. Okay, and we are comparing it with medium 1. So we'll write like this. When it is written n to 1, that means we are finding refractive index of medium 2 with respect to medium 1. Okay, the one whose we are finding will be written first. Okay, now refractive index means what? Now refractive index means the ratio of the speed of light in the two mediums. Okay, so now it will be, we are finding of 2. So what we'll write, it is refractive index of 2 divided by refractive index of 1. Refractive index, we are finding refractive index of medium 2 with respect to medium 1, and its formula is refractive index of medium 2 upon refractive index of medium 1. It is written like this. Now putting the values, what is n2? N2 means refractive index of medium 2, and we have studied that refractive index means c by v. Okay, now putting the value of n2 here. Now this is medium 2, so here we will take 2. So the values will be c upon v2. Okay, upon. Now putting the values of this refractive index of medium 1, again this will be c upon v1. When this will go up, so what will happen here now? This will be now c upon v2 multiply by v1 upon c. This will be turned up like this. Okay, now here what will happen? C and C get cancelled. So what is the remaining thing now? v1 upon v2. Like this you can find out. So the answer is v1 upon v2. Okay, means refractive index of medium 2 with respect to medium 1 is equal to v1 by v2. Okay, and if we are finding refractive index of medium 1 with respect to medium 2, then we'll write it like this. Now this will be equal to n1 upon n2. The one whose we are finding will be taken up now. Now putting the values, this will be c upon v1 and this will be c upon v2. And if you cross it now, what will left? C upon v1 multiply by v2 upon c. So C get cancelled. What is left now, students? V2 upon V1. Okay, V2 upon V1, this one. This is the value for refractive index of medium 1 with respect to medium 2. Fine. Now, on multiplying these two, on multiply means this one and this first and this one, if we multiply means v1 upon v2 which we got first, and then multiply by v2 upon v1, then we get 1. Okay, that means they both are reciprocal na? From here only you can see that if refractive index of medium 2 with respect to medium 1 is v1 upon v2, and refractive index of medium 1 with respect to 2 is v2 upon v1, so both are reciprocal of each other. Fine. So we can write that refractive index of medium 2 with respect to 1 is reciprocal of refractive index of medium 1 with 2, means 1 upon n2, because both are opposite to each other. Fine. They are reciprocals of each other. Okay. So this is relative refractive index. When both the mediums are different, neither of them is air. One could be glass, other could be water, one could be kerosene, other could be milk, like this. So the two medium are different other than air. When we take, then it is relative. And if one is air, definitely if one is air, then the term used is absolute refractive index. Okay. Now, moving on to next one, what is the cause of refraction? Okay, what is the cause now? The basic cause of refraction is why refraction occurs, why light bends. The reason is change in the speed of light. Change in the speed of light when it enters from one medium to another medium. Suppose it is entering from air to water. So what happens? Speed of the light is changing, and because of that the light bends. Okay. Now, when a ray of light traveling in air enters into glass, now air is a rarer medium and glass is a denser medium naturally. So, speed of light will decrease. Okay. And when speed of light will decrease, it will bend. Fine. Similarly, the opposite case is also there. Okay. Now, next one is laws of refraction. First one, there are three laws like reflection. For refraction also there are three laws. First one is whenever light goes from one medium to another, the frequency of the light does not change. Means what we are saying is speed of the light is changing, but frequency of the light is not changing. However, the velocity of light and wavelength of the light change. Okay, frequency will not change, velocity and wavelength of the light will change. This is first law. Fine. Second law is that incident ray, refracted ray and normal to the interface of two medium at the point of incidence, they all lie in the same plane. Incident ray, refracted ray, normal, they all lie in the same plane. This is law 2. Now very important, which comes in the exam also, that is law number 3, which is also known as Snell's law of refraction. Let us see what is this. The definition or the sentence formation of this Snell's law is, it is the product of refractive index. How we show the refractive index? By n. So, product of refractive index in sine of angle of incidence. Sine, you have studied in maths, trigonometry. Okay. Sine theta, cos theta, this is that sine. Sine of angle of incidence, which is shown by sine I, is a constant. When you multiply refractive index and sine of angle I, means sine value of angle I, then it is a constant value. It's a constant value. Okay. Now, whenever there is refraction, we have two medium. So, for two medium, now how this can be written? So, for medium 1, n will be n1 and angle I will be ni, and for medium 2 is n2 and angle of incidence will be I2. Okay. Now, this was constant, so we are comparing with the two mediums now. So for one medium, it is n1 sine I1, and for the second medium, it is n2 sine I2. Both are equal because this value is a constant value. So we are comparing now of two, because in refraction we have two mediums. But you have seen that in case of refraction, this I1 could be written as I, but I2 is not there. I2 could be replaced with R. In the second medium, what we have? Angle of refraction. So in place of I2, we can write R. Fine. So now the changed statement is n1 sine I is equal to n2 sine R. I2, second medium, we don't have angle of incidence, we have angle of refraction. So we can write it R here. Now, See sin I. Now we are finding the ratio of sin I upon sin R. So from this statement, we are finding sin I upon sin R. So what will happen? This sin R will go down and this n will come this side. So sin I upon sin R is equal to n2 upon n1. Okay. And n2 upon n1 is the value of, you have studied just now. It is the value of refractive index of medium 2 with respect to medium 1, n21. Okay, n2 upon n1 is the value of n21. That is, the ratio of sine of angle incidence to sine of refraction is constant value. This value will be constant of the two pairs of media always. And this is called the Snell's law of refraction. Okay, this is called the Snell's law of refraction. You have to remember this line. This is the statement for Snell's law. What is the statement you have to remember? That sin I upon sin R is equal to n2 upon n1. This is Snell's law of refraction. Okay, I hope this is clear. This is little different from the other topics. So if you will read it twice, thrice, you'll come to know. It's not so much difficult, but still, if you will have doubts, you can ask anytime. Okay. Now let's move on and see how we can find the direction of bending of light, whether the light will bend towards normal or away from the normal. So case number one, in going from a rarer to denser medium, what happens? Now here is the rarer medium and this one is the denser medium, fine. So light is traveling from rarer to denser. So this could be found only by Snell's law. Now what is Snell's law? Sin I upon sin R is equal to n2 by n1. Okay. Now what is n2? Which is medium 2? Medium 2 is this one. This is medium 1. This is medium 2. Now our medium 2 is denser medium. So n2, in place of n2 we can write nd, means refractive index of denser one. And in place of 1 we can put the value nr, means refractive index of rarer one. Okay. Now refractive index of denser one will be always higher. Fine. Refractive index of a denser medium. More the refractive index, more denser is the medium. Remember this. So if we'll find the value of this, now n, the value of refractive index of denser one is always greater than rarer one. So if we'll find the value, this will always comes greater than 1. Fine, greater than 1. Suppose of denser it is 4 and for rarer suppose the refractive index is 3. So if we'll divide, the value will definitely come greater than 1. Greater than 1. Okay. So now, so if this value comes greater than 1, then definitely this, if you'll see now this part. So what does it mean? That sin I is greater than sin R. If refractive index of denser is greater and this is equal sign here, that means if this one is greater, then sin I, numerators are greater. So sin I is greater than sin R. Okay. And if I is greater than R, if I is greater than R, that means what? R is less. That means light has bended towards normal, right? This clearly shows that light has bended towards normal. Okay. So using Snell's law, we can find the direction of bending of light. This is case number 1. When light travels from rarer to denser. Now let's see in case number 2, when light travels from a denser medium. This is denser medium now and this is rarer medium. Light is traveling from denser to rarer now. So what will happen in this case? Again using Snell's law. Snell's law is what? n2 upon n1. Fine. Our n2 is what? Our n2 is rarer medium and our n1 is denser medium. This is 1 and this is medium number 2. Fine. Now refractive index of rarer one will be always less, and if numerator is a less value, that means the value is like this, less than 1. This ratio will come less than 1. If refractive index of rarer is less, that means I will be less. Numerators we are comparing, this is equal to sign in between. That means I is less than R. If I is less than R, that means what? R is more. R is more. That means light is bended away from the normal. Light is bended away from the normal. Okay. So these were the two cases in which we can find the direction of bending of light. Fine. Now, what is the condition for no refraction? What happens or what are the conditions where refraction does not occur? So what is case number 1? When light is incident normally, you can see light is incident normally here. Light is making a 90-degree angle with the boundary. So according to Snell's law, what will happen here? Sin I upon sin r is equal to n2 upon n1. Now, sin r is what? We don't know the angle of refraction. We are finding where the light will bend. So we are finding sin r. So sin r will be, now this sin I will go that side. So n1 upon n2 into sin I. Okay. Now sin r is equal to n1 upon n2 sin 0, I. Now sin I is what? What is the value of angle I? Angle I is 0 because I is what? Angle I is the angle which the incident ray makes with the normal. Now here light is incident at 90 degree. So angle I is 0. Normal and light ray are on the same track. So I is 0. So if you multiply anything with 0, it comes to 0. That means angle R is also 0. Angle R is 0, that means light will go straight. There will be no refraction. Okay. So what is the case where there is no refraction? That when light is incident normally. Okay. Now another case is when the refractive indices of two media are equal. If sign this refractive index of both n2 and n1 are same. Okay, if n2 and n1 are same, refractive index of this medium and refractive index of this medium, if they both are same, then n2 upon n1 both are same, that means the value will be 1. Fine, value will be 1. Then what will happen? I is equal to r. I is equal to r, which is not possible in case of refraction. Okay, with angle I is equal to angle r and these are not equal to 0. So in this case also what will happen? No refraction. Refractive indices are same, so light will travel straight. No refraction, no bending, light will go straight. So these are the two cases. Okay, if the light is incident normally or if when the refractive indices of the two mediums are same, in both the conditions there is no refraction. Fine. Now, two refractions through a rectangular glass slab. Refraction through a rectangular glass slab. Now here you can see there is a rectangular glass which has four vertices A, B, C and D. Now this is the rarer medium air and this is the glass now. So now you can see here the incident ray. This is the normal. So this is one point where refraction occurs, and here you can see when the light again comes out of the slab, rectangular glass slab here. So at these 2 points refraction is occurring. Okay. Now when light enters from rarer to denser medium. Now you have studied that when light enters from rarer to denser, speed of light will reduce and it will bend towards normal. So you can see here angle I is more and angle R is left. That means it is bended towards normal. Fine. Now this was incident ray, but when it bends it is called refracted ray. Now at this point again, what will happen? At this point again we have to draw a normal because now light will come out of the glass slab. So here again we have drawn a normal. Now light is coming from denser medium to rarer medium. So what will happen? Now light will move away from the normal. So it has shifted like this. And one more thing to notice, that if light has not bended throughout this whole process, then light would have gone like this, straight, right? But it is bended twice. So you can see here that if light would have gone straight, then this would be the path. But actually light is coming here. So shift, this shift of the light from this path to this path is called the lateral shift or the lateral displacement. Fine, this is called the lateral displacement or the lateral shift. Okay, so this is all written over here. Same thing is written, which I have now just explained to you. Now, angle of emergence E at secondary boundary of glass slab is equal to angle I. Here to remember that angle I is equal to angle E. Okay, just once let's have a look. This is angle of incidence. This with the normal is angle of refraction. This again is angle R. But this ray which is coming out is known as the emergent ray. And emergent ray makes an angle E with the normal. This is E. Okay. In refraction we have studied that angle I is never equal to angle R. But in case of rectangular glass slab, angle I is always equal to angle E. Because you can see that this incident ray is parallel to the emergent ray. Angle incident ray and emergent ray, which is coming out as emergent ray, they both are parallel, which you can see through the lateral displacement. That's why angle I is always equal to angle E. Angle I is always equal to angle E in case of rectangular glass slab. Okay. Light emerges from rectangular glass slab in a direction parallel to that in which it entered the glass slab. Okay, so this incident ray, which would have gone like this, but due to change in the medium, it has refracted. But the emergent ray finally which is coming out is parallel to the incident ray. And this deviation of the incident ray from its original path, okay, that is called the lateral displacement. Okay, or you can say the distance between these two is also lateral displacement. Fine. So this is the lateral displacement. The sideways shift of the emergent ray from the direction of original incident ray is called the lateral displacement, and it is represented by the letter small x. Fine, this is lateral displacement. So in exam, this diagram comes to draw along with its explanation. So at 2 points, refraction has occurred. When the light enters, refraction occurs, and when the light exits from the rectangular glass slab, then also refraction occurs. Fine. Now at both the points we have drawn the normal, okay, and angle I is always equal to angle E here. This is angle of emergence, and inner both the angles are angle of refraction. Right? Now let's have a look on the summary what we did today. So we have done what is refraction, absolute refractive index, relative refractive index, what is the cause of refraction, laws of refraction, how the light bends, conditions for no refraction, and then refraction through the glass slab. So these many topics we have covered today. I think you all have understood. If not, please go through the chapter, read it twice, do watch the videos again and again so that the concepts will be clear to you all. Okay. So we'll meet in the next session. Till then, stay home, stay safe, and goodbye.